I'm Anil Kumar. Welcome to my series on test papers. Let me thank all my students for sharing their test papers and giving me this opportunity to make such videos. We are going to discuss a complete paper on trigonometry. This should be done without calculator. So let's see the type of questions in this test paper. You can always pause the video, copy the questions, solve, and then look into my suggestions. Question number 1 is to use trigonometric formulas to write a single sine and cosine function. Question number 2 and 3 are to sketch trigonometric functions. Question number 4 is to find equation of a sine curve from the graph. Question number 5 and 6, as you can see here, you need to find the expressions value, sine theta, secant 2 theta, tan 2 theta. The last question here is to determine exact value of cos of minus 7 pi by 12. Now we have some questions related to trigonometric equations. These should be solved within the given interval as discussed. Then question number 11, we are given cosecant A in quadrant 2, cos B in quadrant 4, and we need to determine the value of sine of A minus 2B. Question 12 and 13 are to prove trigonometric identities involving double angles. Perfect. So I hope you got a copy of these questions now. You can work on these questions as we take them one by one to solve. Now let us solve these questions one by one. Now in my solution, I'll also provide you with the formula and some explanation. So this video may be about 45 minutes long. Question number 1. Express as a single sine or cosine function A 1 over 4 sine theta by 2 cos theta by 2. We will use double angle formula, which is sine 2a equals to 2 sine a cos a, correct? In part B, we have 6 sine square 3 theta minus 3. We'll use the double angle formula relating cos 2a equals to 1 minus 2 sine square a, right? So these are the formulas which will be used. So let us see how to apply these formulas to get our result, right? So we are given 1 over 4 sine theta by 2 cos theta by 2. To get 2 times, we will actually write this as 1 over 8 times 2. So that is 1/4, correct? Of sine theta by 2 cos theta by 2. Now we can apply the double angle formula, correct? So think like this. It becomes simpler, right? So we have 1 over 8 sine twice this angle, right? So 2 times theta by 2. So that gives you 1 over 8 sine theta as the result. Perfect. So these are all the steps involved. Second, 6, let's rewrite the question. 6 sine square 3 theta minus 3. So we can take 3 common. So if I take 3 common, let me take first 3 common. Okay. So sine square 3 theta minus 1. But here you see 1 minus 2. I'm sorry, 2. 2 times, right? Because 3 times 2 is 6. So if I make it minus 3, then we get exactly how it is written here. Correct? So we get minus. I've taken common. So I could write this as 1 minus 2 sine square 3 theta. Correct? Now if you match, you can write this as minus 3 cos of twice this angle, which is 6 theta. So that is how you are going to solve the first question. Straightforward, direct application of a formula, right? So that is the result. So let's move on and take question number 2. You need to sketch minus 3 sine 2x minus pi on the interval minus pi by 2 to 3 pi. Now in such questions, you should actually first, let me write the equation given to us, which is minus 3 sine of 2x minus pi. So I can write this as minus 3 sine of 2 common, right? X minus pi by 2. So that really gives you the correct phase shift, right? Now here we know the value of k is 2. So the time period t is 2 pi by 2, which is pi. Amplitude A is 3. Phase shift is pi by 2, right? Correct? And also this part is a reflection. So we have that minus is the reflection on x-axis. That is to say that the graph will actually go like this. Do you see that? So it will go in the towards downwards. That is how the graph is going to be. Now I'm going to sketch this function in 2 steps. So let me just take this up here. Now, since the axis is along the x-axis, so the axis is y equals to 0, okay? So that's the axis. So we have a maximum value, let's say, which is 3, minus 3 is our minimum value. So I'm writing this. I mean, this is just a rough sketch since I don't have a graph paper here. This is minus 3, that is 0. Now, we need to sketch in the interval from minus pi by 2 to 3 pi. And since time period is pi, we are looking for 3 cycles, right? So that means 3 cycles. Correct? So let me sketch, since it is reflected on the x-axis, I'll first sketch 3 cycles going like this. So that's the first cycle. Okay, second cycle. This is the third cycle, right? So I'm just extending, okay? So that is how the graph of the function, this function which I have sketched here, is y equals to minus 3 sine 2x. So I have not incorporated the phase shift. You get my point. So in this particular case, if you see one time period is pi. So this is pi for me, second 2 pi. That is 3 pi, correct? So let's say somewhere here we have 4 pi. We need to sketch from pi by 2, and also we have a shift of pi by 2 to the right. So let me now incorporate the shift, and now I'm going to sketch y equals to minus 3 sine of 2x minus pi, correct? So I'm going to shift everything pi by 2 to the right. What is pi by 2 for me? So that is pi by 2, correct? So this is pi by 2. 1 pi by 2, 2 pi by 2, this is 3 pi by 2. 4 pi by 2, 5 pi by 2, 6 and 7 pi by 2. Correct? So what I'm trying to say here, that the whole graph will actually shift by pi by 2. So this point here, let's talk about zeros, will shift to that, right? So this 0 is going to shift. So our graph will start from here. And then the minimum shifts by pi by 2, in between, right? Now this goes in between. And this 0 goes there. that 0 comes on this point, so this goes there. And so likewise, what we are going to do is shift each and every point by pi by 2, right? So all these minimums will come here. The zeros will move to the next 0, correct? So as you can see, we got all our points in place, and I can now sketch the graph of our sine function required. That's it. So the graph is from pi by 2 to 3 pi as shown here. Does it make sense to you? Correct? So that is simplest way of sketching the curves. So my suggestion here is always use 2 steps. So that is our step number 1, and this is the final step number 2, where we incorporate the phase shift, right? So here we have phase shift pi by 2, right? Perfect. So that is how you're going to do it. Now let's take up the next question, which is sketch the graph of y equals to absolute value of 1 plus 2 sine x on the interval minus pi by 2 to 2 pi. So I'd like you to pause the video, sketch this graph, and then look into my suggestions. Let us see how to sketch this function. So we'll again sketch it in 2 steps. First step will be y equals to, let me write this as 2 sine x plus 1. And the second step will be to sketch, let me not call this as y, okay, it's because y is our main function. Say y equals to absolute value of 2 sine x plus 1, correct? So first we'll just, let's say, call it a function g, which will be a simple sine graph, right? So let's sketch the sine function now. Now, the axis is 1, so that means the graph moves 1 unit up, right? So that is vertical 1 unit up, right? So let's do it like this. Then after that, we have maximum should be, amplitude is 2. So maximum will be 3, right? So let me just. So these are rough sketches, but they are fairly accurate, right? So we have this 2 amplitude, right? So maximum will be at 3. Going down, minimum will be minus 1. Perfect. So that is the limit through which the graph will go. There is no phase shift in it. So we'll just sketch our graph, which is sine function, and we have to do in the interval minus pi by 2 to 2 pi. That means 2 cycles, right? So okay, so basically I have to go on this side also. So let me sketch kind of like this. I don't really have space here, but okay. So I'll make 2 cycles. Okay, so that is the graph for us where this is 0. Now, so one wave time period here is 2 pi, so that is 2 pi. Okay, so this much is pi by 2, this is pi for us. So the maximum and minimum will be at minus pi by 2. This is our first function, which is without absolute. Is that okay? Now, we need to do absolute. So when you do absolute of a value, then the negative portion becomes positive. You get an idea. So it gets added on to the value. Correct? Now, what we have here is 3. This is minus 1, and that is plus 1 for us. This is 1 down, so it will go 1 up. So let me sketch this with a red ink, different ink. Okay. So this portion here will be reflected. So when we do absolute function, right, so this portion will be reflected. So we have this as like this. Does it make sense to you? So that is what will happen to this portion. The positive portion will remain as such, and here again will reflect this, right? So this portion again gets reflected. Do you see that? So a reflection will be there in these negative portions. Correct? So the graph which we will have is, this is from minus pi by 2, right? So it will be kind of like this. Reflected like this, and that is the portion which is between minus pi by 2 to 2 pi. So we have one cycle here. Is that clear? Right? So that is how it should be drawn. Perfect. So let's move on and take the next question, which is question number 4. Write the cosine function for the following graph. Okay. So let's look into the time period of this particular graph. So we have a maximum here. Let me write down these values. This maximum is at 30 degrees, right? So I've not mentioned degrees, but let me write 30 degrees and 4. So we're going to use this point. And on this side, we have a minimum, which is at minus 30 degrees, and the value is minus 2. Perfect. Now, keeping that in view, I'd like you to pause the video and write the equation of this. We want cosine function. Perfect? Okay. So let's go with the axis. Axis will be maximum plus minimum, which is 4 plus minus 2 divided by 2. So that is 2 over 2, 1. So the axis of this graph is at 1. Okay? So that is the axis. Fine. From the axis, from 1 to 4, we get the amplitude, let's say just A. The amplitude here is 4 minus 1, which is 3. Now, as far as the cosine function is concerned, cosine function starts with a maximum. So, in our case, it is starting from 30. Therefore, the phase shift is 30 degrees, right? So 30 degrees right. So time period T is given to us between 30 to minus 30, and this is just half the wave. So it is 2 times 30 minus minus 30. So that gives you 60 times 2, 120 degrees, right? So the time period is 120. So therefore the value of K will be 360 degrees divided by 120 degrees, and that is 3 times. Now we can write cosine function. Y equals to the amplitude 3, and we want cosine. K is 3. X phase shift is 30 degrees, so minus 30 degrees. And we shift it up by 1 unit. Do you see that part? So that is how you get your equation. Perfect? So I hope the steps are absolutely clear. Let's move on and take question number 5. I'd like you to pause the video, answer this question, and then look into my suggestions. Question number 5. The line with equation y equals to 3 over 4x minus 1 makes an acute angle theta with the positive x-axis. Find the value of sine theta, secant 2 theta, and tan 2 theta. Let's try to understand the situation here. So we have a line which makes an angle. So it starts with minus 1. Slope is 3 over 4. So let me just draw a line like this, correct? So basically what we understand from here is that, well, this is minus 1. that at any point the slope is 3 over 4. Correct? So if I draw any angle, let me draw it here. Right? So in that case, the ratio of height to the base of this triangle is 3:4. We need not calculate x and y intercepts or things like this. Just sketch it, right? Y intercept is -1, you know it. So the angle which we are talking about, theta, is right there. Now in this particular triangle, 3 over 4, that means rise over run, right? Which clearly I have shown. So this side should be equal to 5, right? Right triangle. So it is 3 square plus 4 square square root, which is square root of 25. It has to be positive always. So 5, correct? So we can write down the value of sine theta as equal to 3 over 5. So that is part A. B, secant 2 theta. So secant 2 theta, let's do B here, which is secant 2 theta, or you could write this as 1 over cos 2 theta. Since we know what sine is, I could always write using the formula sec cos 2 theta, which we discussed earlier also, as 1 minus 2 sine square theta, correct? So that gives you 1 minus 2. Sine theta is 3 over 5, so we have 3 over 5 whole square. The calculator is not allowed, okay? That's kind of important. So which is 1 over, now this is 5 square, right? Which is 25. So we can write this as 25 minus 2 times, this is 9, right? So 18. Everything over 25, so I can take it up here. So it becomes 25, right? So like this. So that gives you the value as 25 over 25 minus 18, which is 7. Right? So secant 2 theta is 25 over 7. Perfect. Now let's calculate what is tan 2 theta equals to. Now tan 2 theta, using the formula, right? So we have tan A plus tan B, so which is 2 tan theta over 1 minus tan A tan B, or tan square theta, correct? So from here, you know what is the value of tan theta. Tan theta is 3 over 4. This slope m, do you see that? So let's substitute this value here. So we get this as equals to twice 3 over 4 over 1 minus square of this. So I'm writing 9 over 16. Is it okay? Now, multiplying everything by 16, we get in the denominator 16 minus 9. And if I multiply numerator by 16, then 16 and 4, we get 4 here. 4 times 2, 8. 8 times 3, 24. You get it, right? So what we did was, we just times everything by 16, right? So 16 times 16 minus 9 comes in the denominator. Now here, we'll do 8 times 3, 24, and get our result, right? So we have 24 over 16 minus 10 is 6, but it is 9, so it'll be 7 again. So we get 24 over 7 as the value of tan 2 theta. So I hope you find this calculation simple enough. And that is how you could work with fractions and get your result without calculator. Good. Question number 6. Determine exact value of cos of 7 minus 7 pi by 12. Now when you do cos of minus 7 pi by 12, you could do in different ways. So one method here is, which I like, think about it like this, minus 7 pi by 12. So if you are going in this direction, correct, you will land up somewhere here. That will be your minus 7 pi by 12, correct? Since this is minus 12 pi by 12. Perfect. So in that case, the beta, the related acute angle over here, is 7 and 5 gives you 12, so it is 5 pi by 12. Now, since we are talking about cosine of a value, and we know cos is positive here, all are positive, sine and tan is positive. So if I sketch it on in the quadrant 1, a triangle with this angle here as 5 pi by 12, I could write this as, let me rewrite and show you. So I can write cos of minus 7 pi by 12 as equal to minus of cos of 5 pi by 12. Do you get the idea? So if you do all this, you could write in this fashion. Perfect? You could do that, right? So this is kind of, those who understand cofunctions and related acute angle, for them this should not be very difficult. Or you could also straight away write this particular function as cos of pi by 4 minus 5 pi by 6. Right? You could do that also. Or you could write this as cos of pi by 4 minus 5 pi by 6. So that will also give you what I'm trying to say. Perfect. But what I will do, I'll adopt this approach. So you could expand this and get your answer. But what I'm doing here is using related acute angle. Writing cos of minus 7 pi by 12 as equal to minus cos 5 pi by 12. Do you get the idea? So that is how I'm going to do. So we could write this as minus cos of, now 5 pi by 12 I have to break up. So I could break this up as 3 pi plus 2 pi by 12. So we're taking few steps here just to make you understand. So 3 pi by 12 means pi by 4, right? So it is pi by 4 plus 2 pi by 12 means pi by 6. And now we are going to use the cosine formula, which is cos A cos B minus sin A sin B. So it is cos of pi by 4 cos of pi by 6 minus sine of pi by 4 sine of pi by 6. Do you see that part? Now we'll use our special triangles. So that is one triangle and this is the other one. So in this triangle where we have pi by 6 as that angle, the sides are 1 to square root 3. The pi by 4 has, it's better to write 2 here and square root 2 and square root 2. So we don't have to rationalize. You get the idea. Well, we can also open this bracket. Multiplying by negative will give us a negative cos of pi by 4 times cos of pi by 6 plus sine of pi by 4 times sine of pi by 6. Correct? Now cos pi by 4 is square root 2 over 2. So we'll write this as minus square root 2 over 2. Sine, cos of pi by 6 is square root 3 over 2. Plus cosine square root 2 over 2, and cosine of pi by 6 is half. So as you can see here, 2 times 2, 4 is our common denominator, right? In the numerator, we have minus square root 2 times 3, 6. And here we get plus square root 2. So the answer is square root 2 minus square root 6 over 4. Perfect. So that is how we could solve this question. You could actually write it in this fashion, apply the formula and get same result. Is it okay? But remember, when you do 5 pi by 6, you are actually in this quadrant where sine is going to be positive, cosine will be negative. That is your answer. Now here is a trigonometric equation. Let's take a break before we get into trigonometric equations and identities. And after the break, we'll solve all these questions. Thank you and all the best.